Hello my dear students of class 6, welcome to physics class once again as I am teaching you chapter number 3 force, and today I am going to teach you the new topic of this chapter, effects of force. Now what is this effects of force? You know that force cannot be seen. We cannot see the force. Can you see the force? No, you cannot see the force, but we can feel or we can see the effect of the force. Okay, its effect can be seen. We cannot see the force, but its effects, or we can feel the force. Okay, so in this topic we are going to learn about the different effects of force. Okay, so number one is that force can start to move an object at rest. This means that when the object is at rest, when the object is not moving, force can make that object move. Okay, the force can make the object move. For example, you can see the football. This football is not moving, the football is at rest. But when I will apply the force, when I will kick this football, it will start moving. When I will kick this ball, it will start moving. That means I have applied the force with the help of my foot, and the ball start moving. So I hope you have understood number one, that force can make the object move that is at rest. Now what is number two effect? Force can stop a moving object if it is applied in the direction opposite to the motion. Now when the object is moving, okay, the object is moving, so how the object will stop? If we will apply the force opposite in the direction to the motion of the object, we will apply the force to make it stop. Okay, so for example, a football being stopped by a goalkeeper. You have seen the football match, and you see that how the goalkeeper stopped the football. Okay, or you can take the example that you can see the ball is moving. Okay, so how this ball will stop? When we will apply the force in the opposite direction. In the opposite direction, no, if we will apply the force in the same direction, the ball will again start to move. So we have to apply the force in the opposite direction in order to stop it. Now third effect of force. Now what is the third effect of force? So let us see. Force can change the direction of the motion of an object. So this means that in first two effects, what I said, that force can start the object which is at rest, and force can stop the moving object. Okay. Now in the third effect, force can even change the direction of the moving object. When the object is in motion, by applying the force we can change the direction of the moving object. Now for example, everyone likes to play cricket. Okay. So when you are batting, then someone throws ball towards you, and the ball is in what? It is in motion. The ball is in motion. No, the ball is moving. It is in motion. And you can change the direction of this ball. You can change the direction of this ball by applying the force on the ball through a bat. With the help of bat, you can apply the force on the ball and you can change the direction of the moving ball. Okay. So I hope you have understood the third effect of force also. Even when you play play football, then what you do, someone kick from that side, someone kick from this side. So what you do, by applying the force, you are changing the direction of the ball. Okay, so force can change the direction of the motion of an object. Okay, now the fourth one is that force can change the speed of a moving object. Now by applying the force, we can change the speed of a moving object. This means that when the object is in motion, when the object is moving, okay, so by applying the force, we can make the object go either slower or faster. When the object is moving, By applying the force, we can make the object to move slower or we can make the object to move faster. For example, if you are walking with a trolley, applying force in the direction of its movement can increase its speed. When you are moving with the, when you are walking with the trolley, okay, and you are applying the force in the direction of its movement, so what it will happen? It will increase the speed. And when you will decrease the force, so what will happen? It can slow down. Is it or not? So force can change the speed of a moving object. Okay. Now let us see the last effect of force. What it is? Force can change the shape of an object but not the mass. Now by applying the force, we can even change the shape of the object, but mass will not change. What will be the mass? Mass will remain same, but we can change the shape of an object. Okay. Now you have seen the dough, no? Your mother make dough with the help of flour. Okay, help of flour she make the what? Dough. And you have seen, no, the dough can change the shape when we apply the force. Okay, so what will happen? It will change the shape, no? When we make the chapatis of this, so what you see? By applying the force, the dough changes its shape. First we make the round shape, then we then we roll it into the chapatis. So what you see, that it has changed the shape, but mass will not change. Mass will remain same. Okay, mass will not change, mass will remain same. Okay, so I hope you have understood these effects of force. Number one, keep in your mind that force can start the object which is at rest. Okay, with the object which is not moving, the force can start that object. Number two is that when the object is moving, okay, so we can stop that object by applying the force in the opposite direction to the motion of the object. Number three, we can change the direction of a moving object by applying the force. Number four, we can even change the speed of the moving object by applying the force. Number four is that we can change the shape of an object, okay, by applying the force, but not the mass. Mass will be same, but the shape will change. By applying the force, we can change the shape. There are many examples of these effects. Okay. So now let us see the other topic. Now the next point is about the unit of force. So what is the SI unit of force? SI unit of force is Newton. Okay. And the symbol of Newton is N. Capital N. We write the symbol in capital N. Why capital N? Because Newton is named after a person, and you know that when the unit is named after a person, then the symbol is written in capital letter. Okay. I have already taught you in my previous chapter about this rules of SI unit. Now let us learn about the resultant force. Now what is this resultant force? In many situations, there is more than one force acting on a body. Okay. On a body, there are more than one force acting on it. Okay. So the total force, more than one force is acting on a body, no? Then the total force, or you can say the net force, which is applied on the body, is called the resultant force. Okay. The total force applied on a body is called the resultant force. Now you can see in the first case that when two forces are acting in the same direction, you can see that two forces are acting on this body, on this object. Okay. And they are acting in the same direction. You can see the direction, the arrow, they are acting in the same direction. Then how to get the resultant force? By adding the two forces. By adding the two forces, we will get the resultant force. And when you will add? When the force is acting in the same direction. When the force is acting in the same direction, at that time you will add. Then you will get the resultant force. Okay. To find the resultant force, when the force is acting in the same direction, what you have to do? You have to add. So 10 plus 20 is what? 30 Newton. N is the symbol of Newton. Okay. And this is the SI unit of force. Okay. Now in the second case, if two forces are acting in the opposite direction, you can see that the forces are acting in the opposite direction. And you can see that one force is greater and one force is smaller. Okay. When the two forces are acting in the opposite direction and one force is greater than the other, one is 70 Newton and one is 50 Newton. Then how to find the resultant force? We have to find the difference of the two forces. Then only we will get the resultant force. So 70 Newton minus 50 Newton, how much we will get? 20 Newton. So this is the resultant force. Okay, the net force acting on the body is how much? 20 Newton. Okay. And the body will move in which direction? It will move in the direction which has greater force. So it will move which side? Towards the force 70 Newton. Okay. So the body will move in which direction? It will move in the direction of the greater force. Okay. So now you can see the third. You can see in the third case that there are two forces. And you can see they are equal forces and they are acting what? In the opposite direction. Both are equal forces and they are acting in the opposite direction. So how to get the resultant force? The resultant force will be what? 0. The body will not move. When, okay, if in any case you see that two equal forces are there and they are moving in the opposite direction, then the body will not move. The resultant force is 0. Because from both the side, okay, from both the side, the force applied is equal and they are in opposite direction and body will not move. Okay, so you have seen these three cases. Okay, they were the three different cases and we have seen there that the amount means the magnitude and direction of force are very important. You have seen here the amount means magnitude and direction of a force are very important. By the direction of the force only we can calculate the resultant force. Okay, so now we have also seen from this example that so we have also seen that the unbalanced forces can make the object move from the stationary motion. In the first case you have seen that the forces were acting in the same direction. Okay, the forces were acting in the same direction, but you can see now the forces are different. One is of 20 Newton, one is of 10 Newton. In the second case the forces were acting in the opposite direction, but they were of different. One was greater than the other. In the third case you have seen that they were acting in the opposite direction but both the forces were equal. That is why the body does not move. Okay. If the forces are balanced, the object will not move from the stationary position, means when they are at rest the object will not move. Only the object will move when the force is unbalanced. Okay, then only it will move. If the force is balanced, it will not move. Okay. So I hope you have understood the effects of force, SI unit of force and the resultant force and when the object will move. So for today up to this much, I hope you have understood. Thank you.